I am here to give you a pre-submission seminar on my PhD topic, feasibility study of defluoridation techniques using forest under the guidance of Dr. P.B. Nagarnaik and Dr. D.K. Let's just start with the introduction. Water is life for all living beings, but nowadays pure water is available to very few people. Other take more or less contaminated water, and one of the contamination is fluoride. Fluoride ions are extremely toxic to the human body due to strong electronegativity. Fluoride is attached to positively charged calcium, teeth and bones. Fluoride is a salt of element fluorine. Fluorine is the most highly reactive element in halogen family. Fluoride has dual significance. If its content is low or more, it creates a problem. The requirement of fluoride content varies among countries and depend on the geography and the age of the people involved. Fluorine exists in the form of number of minerals, and mainly it is observed in the fluorspar, cryotite and fluorspar. These are the minerals where fluoride is observed. The small amount of are found in seawater, bones and teeth also. Fluoride is more toxic than lead and less toxic than the arsenic. Let us start with the sources. Fluoride passes through the atmosphere, water, soil, rocks and living organisms due to natural phenomena or due to man's activity. Geochemical characteristics of the earth crust, which result from the volcanic and plutonic activities, are the primary source of fluoride. Water and food are the secondary source of fluoride. Industrial discharges also contribute in the fluoride in the groundwater. Let us see the health effect. If its concentration is less than 0.5, it creates a dental caries.
When you show this slide, you should tell us how long the contact time should be. In case, by mistake, I drink a glass of water with more than 4 milligram per liter, do you think I will immediately having skeletal fluorosis?
No, sir. Its concentration is actually
Is
6
it a
mg.
cumulative poison?
Yes, sir.
Is it a cumulative poison?
Yes, sir. Actually,
it accumulates.
It's accumulates.
Then you should tell us the body burden. Means at what body burden, at what gram of the adsorbent, the pollutant in your kilogram of flesh, then the disease comes.
Yes.
So try to get that value body burden.
Yes, sir.
Body burden means up to what concentration in the flesh body can take. Because in the initial concentration, the initial body burden doesn't show up.
Yes, sir.
It shows up only later. If I just take a glass of 4 milligram per liter, I don't get skeletal fluorosis.
Yes, sir.
I hope you understood. So either you have to tell how long, some idea like
Yes, sir.
how long exposure should be.
Continuously for how much time, then this can happen.
The best thing is give us the body burden. Body burden means human body. I hope you understood what is
Yes,
body
sir.
burden.
Yes, sir.
At one concentration in the flesh, the problem starts showing up. So these numbers you should dig out. Okay? Good.
Okay, its concentration is per day 6 mg.
Either that way or per kilogram of the body.
Yeah, that can also be.
Body weight.
Yes, sir. Okay, thank you. These are the symptoms of fluorosis, dental fluorosis. These are the symptoms of skeletal.
It's a very painful thing. Yes, it's a very painful disease.
Yes, sir. This is actually this when the person is affected from
I know,
by
don't worry, I know. Please go ahead.
Go ahead.
Okay. Then the status of fluoride. Worldwide it is a problem. If you see, fluoride is endemic in at least 25 countries across the globe. In India, 66 million people are affected by the fluoride. 6 million children are also affected.
More time to your observations and.
Yes, sir. In India, these are the states those are affected and identified. Fluoride in groundwater. This report is given. So in this report, Rajasthan is one of the states where 100% districts are affected by the fluoride. This data is recent data from 2000 to 2015. So these are the levels and concentration. These are the drinking water standards given by the BIS, ICMR, WHO, USFPH. Then
there is a technique after one district in Andhra Pradesh for fluoride removal.
Nalgonda. It's a very famous technique.
Okay, good.
These are the treatment methods. Those are used for the removal.
Which is the Nalgonda technique here?
Actually, it's a coagulation precipitation technique. I'm not mentioning it. In a present study, this is the adsorption. I have worked about the adsorption. That's why the term adsorption refers to the accumulation of a substance at the interface between two phases, such as liquid, solid and liquid, or solid and gas. The substance that accumulates at the interface is called adsorbent, and the solid on which adsorbent occurs is called adsorbent. Physics-sorption and chemisorption. At the surface of the solid, there are unbalanced forces of attraction which are responsible for the factor controlling adsorption. Basically, nature of adsorbing is one of the factors, then pH of solution, then contact time, initial fluoride concentration, then temperature and the degree of agitation. These are the factors. Now, these are the objectives of my research study: the chemical characterization of the adsorbent, and then the study of the effect of the following parameters, just like effect of dose, effect of pH, effect of contact time, effect of initial concentration, effect of particle size, and column study. And the comparison of adsorption capacity with the already reported adsorbent, and regeneration of material, and finally disposal of larger material. List of adsorbents used. I have identified that adsorbent. These adsorbents are the forest herb. First adsorbent is the Terminalia arjuna, which is very useful adsorbent. Second one is the bark of Philanthus imblica. Third one is the bark of Terminalia cibula, and fourth one is the seed coat of Callisthenia vonda. So these are used in this study. So these adsorbents are used in the form of precursor, in the form of coke, and in the form of modified adsorbent. So comparative study is also there. Collection of adsorbent. Tree bark of Terminalia arjuna collected from the Gadchiroli district, and tree bark of Terminalia cibula also collected from Gadchiroli district. These all barks are collected from Gadchiroli in Sandra Beach. Let's start with this literature review. I have gone through this literature review from the 1998 to 2015. So the concentration, then dose, then pH, then temperature, then agitation, all these parameters were there. We have observed that the better result observed in the modified adsorbent. Then the methodology of the study. Here we have collected the adsorbent, then we have checked first in the form of precursor, and it has found that the dose of that precursor is quite more. Then we have again modified this adsorbent by providing the treatment of providing the physical treatment, and then after again we have seen that whatever the percentage removal and whatever the dose of adsorbent is there, that will be very high. That's why again that material will be was modified by using a chemical process, and then it can be reduced up to earlier. Characterization of adsorbent. In this first, the proximate analysis are done. See the proximate analysis, TAP which is called as Terminalia arjuna precursor, TAC which is called here Terminalia arjuna coke, and TAM which is called here Terminalia arjuna modified bark. So if you see the comparative results of this, we will get maximum carbon concentration in Terminalia arjuna modified bark, that is 42.32. So this concentration, where the maximum concentration of carbon will be available, the maximum porosity and surface area will be available, which helps to the adsorbent.
In the composition here, moisture content, volatile matter, and what is AG?
Which sir?
AC. Left hand side AC. FG is fixed carbon, FC fixed carbon, right? Above fixed carbon, what is AC? Ash content.
Ash content.
AC, okay, ash content. My query is fixed carbon, okay, and volatile matter also contains carbon, right?
Volatile matter?
Also contains carbon.
It creates ash.
No, volatile matter is the combustible fraction.
Yes, sir. It is very
That
low.
also contains carbon, right?
It produces carbon but very low. Because whatever the contents are there, that will be burned. And it will convert into ash. And whatever the remaining coke is there, that carbon...
No, I understand. Don't worry. See, you heated it at high temperature, no?
Yes, sir.
What is the... you initially heated at 100 and then at 600, something
Yes,
like that,
sir.
right?
Yes, sir.
So, many volatiles are in fixed. That is why there is a increase in the fixed carbon content, right?
Yes, sir.
There is increase in the fixed carbon. And that carbon comes from the volatile fraction.
Yes, sir.
Yes or no?
Yes, sir. The quantity will be very low.
And ash content, does it include your fixed carbon? No.
No, sir.
You are telling ash are completely inert.
Completely enough.
Non-carbonic.
Yes, sir.
Non-carbon. And Fg is the fixed carbon.
Yes, sir.
Which can burn or which cannot burn? That is my question.
Which sir?
Can it burn? Fixed carbon?
Fixed carbon burn. Yes,
It
sir.
burns.
Completely burn.
So the question is whether your volatile matter contains some amount of carbon or all carbon is accumulated in fixed carbon.
Volatile matter is when we combust that material in absence of oxygen, it will be just burnt.
Volatilized. It will be volatilized.
Yes, sir.
So it can be little bit of sulfur or little bit of hydrogen,
Yes, sir.
carbon also.
Yes,
perhaps.
sir. The CHN.
So in your case, fixed carbon can burn.
Yes, sir. Then these are the results found in Terminalia Arjuna and Terminalia Chebula. Then similar results found in the Philinthus indica and Cassipine bonga. Then the next study is chemical composition. The chemical composition found in the raw material, that chemical compositions are the calcium oxide maximum found in Terminalia Arjuna powder, that is 33.85, which is a very high content and which is useful because calcium has a very good affinity with fluoride. That's why these materials are useful for this study. These are the chemical composition. Then the scanning electron microscopy. Actually, it's a comparison of Terminalia Arjuna precursor and the coke. Initially, I have compared with this. So it has found that when I use precursor and when I use a coke, in coke, maximum pores were observed. It shows that it can be used or it can be feasible for the adsorption process. These are the observations that can be given by the same analysis. So same, in all cases, same observations were observed. It is because of the, at the higher temperature, the material gets degraded and it starts to pouring the material. That's why such kind of results I have found. Then same of modified bath. You see, it is very, that particular material is an unloaded material and this one is a loaded material. So here again the difference. So in unloaded material, if you see that pore size, uneven pore size is there on the surface. And here somewhat that pores were accumulated. Same observation found in all the materials. Then XRD. XRD study, here X-ray diffraction, here says that unloaded, if you see here the total amorphous nature. And in case of unloaded also, loaded also, it can seem that some peaks are there. It means that material can accumulate over the surface. So these are the observations that I have seen in all the atoms. In the point of zero charge. The point of zero charge is the surface charge pH of the adsorbent, at least the net value of the surface has neutral charge. The point of intersection of resulting curve at which delta pH equals to 0 gave the pH PZ. So in this case, in terminal Arjuna TAM, we found 7.2 PEM and TCM we found same pH 6.9 and CBM and 6.6. It just in lower pH the results are good. In the batch absorption study, effect of study on the precursor. Initially I have tried the precursor and what I have observed that the PEP dose was 45 grams per liter. That is the precursor. This is the raw material. I have used that. Then I have again the material has physically characterized we can say that by providing the physical treatment it has the 12 grams per liter. It means it 45 to 12, that ratio is there. Then the TCP case also it can be reduced. In all cases that dose are reduced after the physical treatment. So the obtained doses of all the adsorbents are very high in all the cases of precursor. And hence further the adsorbents were modified chemically for reducing the dose and improving the surface capacity of the adsorbent by using chemical modifications of aluminium sulfate. Let us start the dose study. The dose initially if you see 0.5 gram, 1 gram, 1.5 gram from 0 to that up to 5 gram I have done this study. So 0.20 gram per liter, it was found that the removal is 62.20. So in this case, when the dose get increased, the percentage removal get also increased. But at the time, it will nearly equal to horizontal. So it is because of whatever the uptake capacity of that material is there that get accumulated, and thereafter there will be no surface area to accumulate the ions. So same conditions, nearly same conditions observing all kind of modified parts. Effect of dose again here. In TAM case, there is modified terminal Arjuna case, 93.80% removal were observed. In PEM, 82.27, and in TCM, 82.20, and in CBM, 90.1% removal were observed. Effect of pH again here. This effect of pH study shows that initially the removal of fluoride get increased up to some extent, and after that it will be decreased. It can decrease because of whatever the surface anion surface properties were there. The hydraulic ion compete with the fluoride ions. That's why this kind of result is there. It will be decreased in case of pH. PAM about 92% found in pH, percentage of removal found 92%, pH 9.1, PEM 86% 7.6, TCM 84% 9.3, CBM 90%, pH is 8.7, and thereafter the gradual decrease trend will be. Effect of initial concentration study is also there. Again the same observation Mr. Godbole. Whatever the temperature get increased, percentage removal get decreased. That is the observation. So here, in all the cases, the same kind of results are found. So the effect of contact. This is put the place. Just a minute.
Okay.
In the effect of contact time. The contact time study, here if you see, the more of contact, it will be start, actually the removal will start and maximum removal up to 60 minutes it has observed in this study. up to 60 minutes, 1 hour. Then after there are quite reducing in the percentage of removal. So in all the cases, so clear.
If you redo the whole experiments, or if you get another student when you are a faculty member, try to take maximum readings in the beginning. Don't forget it. I have already told to Ghrce Phd. Okay?
Yes, sir. Yes,
It is
sir.
applicable to you also.
Yes, sir. Yes, sir. Yes. Then for initial concentration 5 mg per liter, 60 minutes achieved. PM 88.2% is 60 minutes, PM 69.2, 65.4 and CPM 85.4% are also. Beyond 60 minutes there was minimum significant increase in the rate of removal. After 240 minutes, percentile removal ceases in case of TIM and CPM, and at the same time after 300 minutes the same case happened in the PM and TCM. Effect of temperature with dose. So here again, dose increases the percentage of removal up to some extent. Then after again, it will be a step. The effect of agitation. The speed of increasing agitation promotes the contact of adsorbent with adsorbent efficiency effectively, and hence the removal efficiency of the all adsorbent increases with increasing agitation. That was the one observation. Second one is it improves oxygenation of the fluoride solution.
You are having 100 ml of water. 100 ml is the sample size, and you are putting 5 milligram or 5. What is the absorbent dose?
Absorbent dose is 0.6 mg per liter.
So mg per liter. So it is
Gram per liter.
Gram per liter. It's a small amount.
Yes, sir.
And you are agitating. So you have to be very careful about this gram. I already told you. I told Ghrce Phd that agitation may be required to some extent, but this looks very high RPM, which may break the physical, if it is physical absorption.
Yes,
So if physical absorption is absolutely rolled out, if physical absorption is also there, then the grass would have been the other way around. Or maybe there would have been an optimum RPM like this. Beyond that, your efficiency will come down. See, normally absorption is a phenomenon which includes both. Then, if you have very high speed, then perhaps, I don't know whether 200 is good enough. It will break the van der Waals forces and the physical absorption is no more in effect. You will have only chemisorption.
Yes,
In that case, gram would have been the other way around, ulta. So, I don't know if you had done more RPM, whether you would have got a gram like this, I don't know.
maybe.
But be careful because it is going on increasing. To my common sense, it says that 100 ml volume and just 1 gram or 2 grams of this thing, whether agitation is such an important parameter, I don't know. You have to be careful when you present it. You can see whether other researchers had varied this parameter, what was their observation, what was the reason given by them. Please study. Because to me it doesn't look that convincing. I think I could not, actually I could not resist. That is why I asked Ghrce Phd the same question. To you also I could not resist myself. And I have to ask you this. So be careful with those things. Okay. Once you want to teach, then you have to
What is
defend
the
it.
optimum agitation you have taken in this? Because you don't got the optimum value.
Yes, sir.
So how you are assuming that 200 is good speed?
Because it is going like this, na?
Actually, on
When you say it is optimum.
optimum, I have selected that because when the removal get increased, at time when I required a concentration of 1 ppm. So whatever the amount I will get, that time I have selected for this.
That cannot be.
Anyway, see the moment you say optimum, then there are values below, values above. That is the meaning of optimum. Na? Otherwise, how can you call it an optimum? For example, temperature. It is going on increasing. So had you done it 100 degree, 200 degree, 400 degree, 1000 degree, do you think the same thing will happen? It will never happen. So be careful in using these terms.
Definitely.
You have to be careful. Perhaps you can do, instead of writing optimum, you can use the within the range of experimental
Yes, sir.
Or based on
procedure.
earlier observations.
Based on the within the range of experiments conducted. For example,
Yes.
you did only 3 temperature range. Within the temperature range tested, it was found to be increasing. Something like that. So within the range tested. Then they can ask you why you did not test below and above. Then you can tell below there was no way to reduce the temperature. Or above that maybe the property of the material will change. I don't know. So you have to find out some good answer for these questions.
Yes, sir, definitely.
So instead of optimum word is actually dangerous. Sir, you agree with me?
Yes, definitely. Way of interpretation should be proper.
Okay, go ahead.
In the language study, assessment studies, in that form, in a language isotherm, the R-square value is nearly equal to 1.
That's not a big thing. Anyway, go ahead.
So these are the observations that I have.
You're not that much worried about R-square. R-square is the way you fit, right?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. Thinking on the
And why both of you tested only 3 isotherms? See, when you start testing, there are many isotherms you would have tested. Perhaps I understand. Frantic, Lanier, these two are the prominent ones, like the monolayer and heterogeneity, all those things. I appreciate that. But there were, anyway you are testing, so you have tested more, for example, BAT.
Bet.
BAT.
Monolayer.
So perhaps you would have tested a bit more. If it is only calculation, then why don't you do it actually? That adds on to the value. You can test more isotherms. I don't know. You can discuss with the supervisor, and if there are no other observations required, with the same data, you can calculate why to limit to these 3. And one more thing, before I forget, I will tell you. When you say isotherm, it's an expression which is trying to model the process. So I would love to see, you are telling Frantic is the best or Lanier is the best? In your case?
In my case, language is best.
Okay. So I would love to see that in the conclusion, yes, this is the model with the constants in place. Give that expression so that people can use it. What is the purpose of all these things? Something should come out of these things. You are telling Langmuir or Fredlich is the best. Agree. If Fredlich is the best, then why don't we give that Fredlich equation with those constants and what is it, AB or N, whatever it is, constants, and put it as an equation so that people can use it. Then it is this combination of adsorbate and adsorbate. Do you agree with me?
Yes.
You don't have to agree with me in everything.
Suggestions are there. The suggestions are
These are all
very false,
suggestions.
That's why.
These are all suggestions. You take everything with a pinch of salt because it's very easy to suggest. For me, I can keep on suggesting up to 5 o'clock until my flight goes. I can keep on giving you suggestion. It's not that you have to accept everything. So you have to see the plus and minus of suggestion, whether it is possible to accept it. I cannot tell you to work for another 2 years and to submit your thesis. I said, no. So you have to see whether suggestions can be implemented. You don't have to give me an answer at the moment. Sit with your supervisor and see whether these suggestions are worth implementing. If yes, go ahead and put it for more. Then one more thing, when you speak about the kinetics, it's pseudo or second order in your case, and in your case?
In pseudo second order.
I would love to see what exactly it means. What is the physical feel of these things? When I say pseudo, anybody can ask you, why pseudo? Why don't you say second order? Why it is pseudo, second order? There must be a reason. So, I would love to see, whatever it is, so I would love to see some physical kind of explanation coming, what exactly it is. Okay? Because you are all dadas now. You have worked for 3-4 years on adsorption. They are all dadas of adsorption, right? I don't know whether it's the right word. I am not Hindi speaking. So if I made a mistake, please pardon me. I am not a Hindi speaking guy. So you are all masters on adsorption. Huh? Okay? So you should be able to explain the physical feel of all those. Okay? Otherwise, it doesn't make any difference. Okay? Just telling equation, it's not a good idea. Don't treat it as a black box. Okay. So when you say pseudo order is the pseudo second order is the one you are following, tell what are the beauty of that, or the what is called the speciality of this equation, and try to highlight it. Okay. Go ahead. It's okay. You can go ahead. He has already explained this. So in your case, Langmuir, no?
Yes, sir.
It's a monolayer, right? Langmuir is
Yes,
a
sir.
mono.
Mono. This is the comparison of maximum removal capacity, QE.
This is what I was looking for, perhaps. Milligram per gram of the adsorbent. This is milligram of fluoride removed per gram of the adsorbent.
Yes.
So, I forgot your name. Sachin.
Ranjit.
Ranjit. So Ranjit is telling it can go up. It can go up to what is the best? Say 15. 15 milligram of fluoride can be removed per gram of 18. 18 milligram of fluoride can remove. Fluoride can be removed by 1 gram of your adsorbent, best adsorbent. What is your case?
So in my
Was there
case
any
it
competition between you two? Kiska adsorbent will remove the maximum.
So in my case it is 2.35.
So there is a big difference.
Big difference.
And he is having the adsorbent carbonaceous. You are having non-carbonaceous. Then I have a problem. Conventionally, this is for you to, sir can also maybe clarify later. Conventionally, we say when the pollutant is inorganic, we are likely to recommend alumina or these kind of things. When the pollutant is, when the adsorbate is organic, like smell, we are trying to recommend activated carbon kind of thing. So, but this is going against that wisdom. Did you understand what I told you just now?
Yes, sir.
It's a conventional wisdom. It's not a hard and fast rule. Whenever the pollutant is organic in nature, for example, odor, I am not telling activated carbon cannot remove the inorganic thing, but it's a general feel that whenever the pollutant is organic, activated carbon is the one normally chosen. Whenever the pollutant is inorganic, then the choice is naturally towards something that is not like activated carbon, something like fly ash or something like your marble dust powder. So you are telling it is 18 and he is telling it's only 2. And fluoride is not organic, I suppose. So this is going against conventional wisdom. Did you understand the question?
Yes, sir.
So you have to sit down and see. Okay, sir, I think I just trying to tell some comparison.
Actually, his in present study highest is 13.69, not 18.
Okay.
18 is from
Compared to
other,
18 is higher.
that is TVS.
This is
So
all.
there is one more term.
In your study, kitna?
13.69.
In your case, the
Mine
same.
is 2.35. So actually difference is I am using a raw material and he is using
Modified
chemical
one.
modified material. That's why he is getting 13.69 and I am getting 2.35. But in 3 cases,
No, in
it is
his
3.35.
case, modified and activation is involved.
Yes, sir.
You heat at 600 degrees centigrade.
Yes,
That
yes,
makes
sir.
a big difference. In your case, there is no
It is a
activation.
normal material.
Normal temperature.
Yes, sir.
Anyway, you have to come up with these kind of answers.
Yes, yes.
People can ask you anything. Okay?
Yes.
Go
So
ahead.
these are the results.
Go ahead. 1 minute. This is breakthrough.
Yes, it's a break.
So this is what I have been asking you. See, time-wise, see, it's actually flat in the beginning, the initial few minutes, and it would have been even 0 if you had taken values before that. And
No, sir.
around 12 minutes, the column is.
Yes, sir. The service time becomes 12. 16 minutes maximum in case of centrifugal.
If I draw a horizontal line where the allowable fluoride concentration is, then where will that horizontal line will come?
Yes, I'm not getting.
If I draw a horizontal line,
Okay.
there is a standard,
Yeah,
no?
that line becomes suppose 16.
No. I am telling about horizontal line, not vertical line. CE is your standard of drinking water, 1.5 milligram per liter. CE.
Yes, sir.
Huh. If CE is 1.5 milligram per liter, CO is what? Initial concentration.
5 is initial concentration. 5 milligrams.
Can I raise it? Anyways, for you also, what I am asking you is CE by CO. If CO is 1.5, I take as the upper limit. I take as the allowable standard, milligram per
Upper
liter.
limit.
Divided by CO, the initial
Initial concentration.
concentration, you get a point here, is it not?
Yes, sir.
Somewhere here. Where is that point coming? Any idea? I want to know whether it is here
Sir,
or
in
here
my case
or
it is
here.
0.9.
Huh?
In my case it is 0.9 horizontal line.
0.9.
Yes, sir.
So it is coming somewhere here.
So in my case,
In your case.
In
आपका
my
case
case.
में?
इस केस में more than a 0.8.
More
Above
than 0.8. By that time the column is almost done. The capacity is almost gone in that case. Anyway, I hope you understood what I am trying to ask you.
Yes, sir.
See, you put the allowable concentration and plot that point here and see. I would have loved to see that value much below, somewhere here. See, my worry is,
Yes.
if you are telling 0.9, it is somewhere here, na? 16
Yes, sir.
minutes. So I can use it for how long? 16 minutes?
It's a R, sorry.
service time.
It's a service time.
Okay. Try to find out
These
where
are
it is.
R's.
Okay.
16 R. By
16.
mistake. It's not it's R, sorry. By mistake it's quoted.
It's not minutes.
It's not minute, it's a R.
Okay. It makes better sense. Are you sure?
Yes, sir, definitely. I'm sure.
I was thinking something is wrong because I am getting a value which is 16 minutes.
No, sir. Actually,
Okay, go ahead.
small kind of sorry for that. huh?
Okay, no problem.
In table is okay.
So sorry for that. Because
Get
here
it.
only
Okay, go ahead.
second stage breakthrough. These are the experimentation.
I remember 5 cycles and 65.
Then the disposal.
What are you proposing?
In this study, desorption of fluoride ion done by commercial ion, that is aluminum sulfate, before use as fill. The fluoride ions will separate effectively by treating spin adsorbent by alkaline acid regenerates and by using alum additive. The solidification or stabilization of sludge into concrete cube bricks and blocks for housing will carry out by cement or lime. This is one of the suggestions. And second suggestion is that
Is it based on some IS codes or guidelines or वो थोड़ा देखना.
yes, sir.
When you suggest something, it should be as per the
Actually,
rules.
study has been carried out by so many researchers.
Plus, I'm sure it's not leachable.
Yes, sir.
Because you only told that fluoride is more toxic than lead and less toxic than acid. In the beginning, I ऐसा बोला था.
Yes, sir.
Then last में you cannot tell that you can use it for something. Okay, so ensure that it's not leachable.
And second one is the further research the disposal of exhaust adsorbent may carry out by seal them into a safe container and then this container may be landfilled.
No, these are all general suggestions. I appreciate, certainly appreciate. But please link it to the rule book.
Yes, sir.
We have hazardous waste management rule book.
Yes, sir.
Okay, so just see how hazardous these things are, how it can be. Because this cannot be officially speaking, as far as my knowledge goes, it may not go to a sanitary landfill. It cannot go. So it should be treated as a hazardous waste. So hazardous waste ka wo dekhe, maybe solidification is required. So wo dekhe, you have to, you can write like this, but you have to show the as per which rule book.
Yes, sir.
Or is there any IS standard speaking?
You go hazardous waste 2008, 2010. That is TCLP test. TCLP test is semi-dynamic, dynamic. Both you have to carry. And it will come.
That is for leachate.
Yeah, leachate, for leachate.
And for disposal, आप देखिए what is the recommendation or what are the recommendations of the hazardous waste rule book. 2012, 2016 में everything has been modified.
Now it is 2014 it is modified.
2016.
16.
Last year everything has been modified. All rule books on MSW, biomedical, hazardous and e-waste.
These are the conclusions.
Previous slide. Previous slide. So in your case, how it is coming?
Actually, terminal Arjuna modified bar as a more feasible material. Then after Cathephinia Gunda, and then after Philinthrica indica, and then after the terminal Chibula. These are the order.
Anybody can ask you why you chose these herbs,
Yes, sir.
not other herbs. One answer is others have been tried and this herbs have not been tried. That is not a good answer. So anybody can ask you why you chose these herbs. Okay. So you have to give an answer.
One such that terminal Arjuna Chibula. Actually, it is a particular waste of agriculture industry. And that's why what happened, it's a big problem of use this waste. So, many of the researchers tried to remove it. That's why it is one of the approach towards this. It is one of the approach. And second thing is also, sir, because in rural areas, particularly in Chandrapur and Gadchiroli district, they use tree bark. They remove that tree bark every day. And what happened? That particular get wastage. So we can use that for the purpose of this.
Why do they remove that?
For the glue purpose.
Oh, they get a glue out of it.
Regularly they can use this activity. So one of that approach is also there. We can use that.
Is this previous slide?
Yes,
Is it Akhilendra Gupta? A. Gupta? No. NIT Jaipur. There is one Akhilendra Gupta who has done a lot of work on fluorosis. A. B. Gupta. You can refer to his papers also. A. B. Akhilendra B. Gupta. Akhilendra Bharat, I forgot his full. A. B. Gupta, NIT Jaipur. Extensively worked on fluorosis and fluoride removal.
These are the references. This one I have also tried. Domestic defloridation. It's just one of the trial. So design consideration are considered. In general, an average Indian family consists of 4 members. So considering the daily demand of drinking water per person is 5 liters per day. So total water requirement for a family is 20 liters per day. And the adsorbent can be used in 3 cycles. Because after 3 cycles,
You have a picture of that?
the design is there.
You have a figure of that?
Yes, sir. Yes, sir. This kind of the defloridation in the acid.
Dimension?
Actually, it's
This is the
totally-
inside one? Okay.
whatever the result I got on the basis of column analysis, I just here introduced the ceramic candle.
Put the dimensions.
Yes. Yes. This.
Okay then. So we have some general discussion before we break. First of all, before I ask further, I think I wish to congratulate both candidates because after working for 3-4 years, they are on the verge of completing their PhD. So I appreciate that. And I wish to congratulate both of you.
Thank you,
And
sir.
also your supervisor, sir. But I have some observations, and perhaps the idea is to, as I rightly told you in the beginning, to bridge the gap between you and the examiner. So I will try to express my feelings, and I wish that you pass through and you get good appreciation from the examiners. Whenever we speak about adsorption, my problem is I go mad. Because so many people have done adsorption experiment by removing some pollutant or other using some adsorbent or other. So whenever I see a work like this, I literally go mad. Because, oh God, another thesis. Oh God, another research paper. So, I'm telling you from my heart, you can please take it positively.
Yes.
It can be some criticism, but it's okay. You should take it with the right way. So what I feel is, what is lacking? It is innovation. What is lacking is the novelty. In a PhD thesis, what I feel is, even if you have not done anything great, if there is something new, something innovative, something novel, that gets a lot of appreciation. Lots of appreciation. So naturally, a work on adsorption with a kind of conventional pollutant like fluoride. Fluoride has been removed by, you have written in your thesis, so many people have worked, so many different, it's okay, no problem. I am not telling that there is no scope for improvement, but I can tell you, it's very difficult to make it novel or innovative or creative. So there comes your role. Try to give something new, something for the people to look forward to. So in that connection, I have some suggestion which I am very sure you are not going to do. Maybe somebody who works in future can try to do. See how long the fluoride estimation takes. It's a question to you. How long it takes to estimate fluoride in the lab?
7 8 minutes.
10 minutes. The titration.
UV spectrophotometer.
Huh. But you have to add some
Yeah, we have to
reagents
make
and
the reagents.
you need a calibration gram and so on.
Yes.
So what I suggest is, on the field, say in Nalgonda, if you want to use the filter you have designed, people should be able to test fluoride quickly, just like your pH paper. You know, if you have a paper, you just put it in the water and see the color. If the color is too red, very dangerous. If the color is yellow, safe. So can anybody develop such a small thing? I am telling you, it is patentable, you can be a millionaire quickly. This is one thing, quick estimation of anything. I am glad that you told only 10 minutes. I was expecting 1 hour. Even 10 minutes is not easy. But for that you need a spectrophotometer. So I am trying to tell you, if anybody can develop a quick estimation kit, which the rural people can have. For example, this fluoride pollution, normally it is happening, arsenic and fluoride, this is happening in the rural villages. You know, arsenic pollution, similar one. It happens in the rural areas of West Bengal, Bangladesh, some areas. You know, I have myself visited. So the issue is, people were not knowing that the water was polluted. They did not know whether the, you told the filter can be regenerated or reused. When? They should know that their water is having fluoride now. How? They cannot have a spectrophotometer. So if there is something like a litmus paper or something, see, it's too imaginative from my side, but if somebody can develop a paper like this, just touch in water, it gives a different color. You can compare, maybe you can have a standard color paper, you know, different color, or yellow turns to say brown or red, or you know, then you tell, the moment it is above the standard, drinking standard, it becomes red color or some other crazy color. So people can understand that. I'm sure you can't do it. It's too chemistry involved, too much of chemistry involved. But like this, can you give some innovation? That is my question. It's not possible on that side. Then you can give an innovation the way you have done. Try to see the application side. Can you design something for the people which you have done? So a household filter is a good idea. I welcome that. A household filter is a good idea. It was not there perhaps in the report sent to me. So I'm glad to see that that has come. So this is something which I appreciate. So you are getting something out of your work. that is good. So you have to highlight it. Okay, so that is one thing, and try to give a good design with good picture and diagram with dimension.
Yes.
Another way of giving some innovation is try to see which parameter is more sensitive. Is it possible to do a sensitivity analysis and tell that you are actually finding out many different parameters, their influence on absorption, or which parameter is more sensitive? That is one thing which maybe others in future can think about. Okay, so these are some ways of quickly in my mind giving innovation. Okay, and also to improve the thesis, I have a feeling that you have to give the diagrams and some photographs also. And why you have chosen this material? One reason is others have not done, because all material possible of thinking have been tested. That is the problem with absorption experiments. Everything has been tested so well by so many people for heavy metals, for fluoride, for arsenic and whatnot. Okay, so anybody can ask you this question: why you have chosen this? You have to give an answer other than what I told you. These material have not been tested before. That is not a good answer. It's a very bad answer. Okay, so try to find out whether there is a convincing answer. Okay, and there are some parameters which are going against the conventional wisdom. For example, temperature. Carefully you have to see. And RPM. So, okay, so these are some general comments from my side, and maybe I will just glance through whatever I have written from the reports, not based on your main work, but based on the reports sent to me. If I have something, I will ask you right now. I will just quickly glance through these things. Otherwise, I feel I appreciate the quantum of work that you have gone into. And another thing is, I don't know, you do a similarity test, similarity check using a Turnitin or something like that?
Yeah.
So there is a facility to check the similarity index or whatever. So be careful with that, because you two are from the same supervisor, so you two are likely to have similar kind of paragraphs, or I myself have seen some paragraphs are quite similar. Exactly the same line repeating. It's not a mistake as such, but when you check it in with Turnitin, it shows not only the published one, it shows perhaps the already tested ones also. So in that case, you have to be careful, because quite similar. For example, methodology, exactly the same. I am not telling it is wrong, because you have done the same kind of things under the same supervisor. It can be the same, but be careful with that Turnitin or whatever is the software you are using. Okay, so these are all some general observation. Then the language is good, not bad. Language is looking good, and the flow is there. It's written with good flow, and references you can improve. I was expecting around 300 papers, and you have put only 60. One of you have put only 60 or 70. I don't know. I confuse between you two. Kiska kya hai? Anyway, one is written 140.
150 people.
But there are, I think, lots of literature available, especially on fluorosis and absorption. Lot of literature actually. If the work is already done, then you have to be worried about the already published literature. Okay, so a lot of literature are there. Try to see and try to compare whatever your studies are with theirs. The way I was trying to compare between you two, which material was giving more capacity. Okay, and one more thing perhaps this thing is, see, from batch to column and column to field, you can highlight what you are using actually. From batch experiment, what goes to column experiment? From column experiment, what goes to your field kit, I mean field filter? That will be very good for the community and for the, that is a technical contribution. Okay? So these are all some general comments, sir. So I'll just quickly see whether I have noted down something more. I hope we are not that late.
No, sir, no problem.
Normally does it go so long? Or
Yeah.
It goes. Okay.
Only thing at that department have more of seminars.
I won't take more than another time.
Thank you, sir. Thank you very much.
You have to put the photos.
Yes.
Yes, gram of fluoride per gram of adsorbent.
Yes.
I think in one case it is clear, but after case it was not very clear to me. And try to test for more isotherm if possible.
Yes.
Other than the three you have tested, try to see DET and some more if possible. And you have not done the iterative things, but it's okay, your experiments are over. Maybe those who are planning to work in future can go for that cyclic iterative approach. At what end?
Here, reach bar. I have shown. Reach bar. Reach bar. I have shown already.